Hello there, and welcome back to Science for Sleep, a quiet place where we take soft, drifting journeys through some of the most mysterious ideas in science. Tonight, we'll explore something both ancient and deeply intriguing: the long, slow rhythms of Earth's ice ages, and the possibility of the next one arriving in the future, and when that might be. Ice ages are part of Earth's natural cycles. Long before humans existed, the planet slipped in and out of great frozen eras with patient regularity. Glaciers stretched across continents, oceans cooled into quiet blue expanses, and landscapes changed under blankets of ice that moved at the pace of deep geological time. These changes didn't rush. They arrived slowly, lingered for vast stretches of years, and faded just as gradually. Thinking about them brings a sense of the planet breathing in slow planetary rhythms that unfold far beyond the scale of human life. Scientists study these cycles through clues hidden in ice cores, ocean sediments, and ancient rocks. Each layer holds a memory, trapped air from long ago, bits of dust carried by forgotten winds, chemical signatures shaped by temperatures that rose and fell over eons. When these clues are pieced together, they reveal a calm, repeating pattern. Earth warms, then cools. Ice advances, then retreats. The cycle stretches across tens of thousands of years, guided softly by shifts in Earth's orbit and the angle of its axis. These motions change the way sunlight touches the planet, creating long, gentle pulses of climate that have shaped Earth again and again. Tonight, we'll drift through 100 theories, soft, speculative ideas about why ice ages begin, what shapes their rhythms, and how Earth might one day slip quietly into another. Not every theory is certain, and many are simply imaginative possibilities inspired by science. Some ideas come from small variations in Earth's orbit. Others look at changes in the oceans, the atmosphere, or even the brightness of the sun. A few reach into deeper mysteries, shifts in the magnetic field, quiet volcanic cycles, or patterns hidden in ancient sediments. Each idea will be told like a gentle whisper, not as a prediction, but as a calming question. What might guide the next great cooling, far in the future? Before we drift any farther, I invite you, if you feel comfortable, to gently like this video, subscribe to the channel, and share in the comments where you're listening from and what time it is in your corner of the world. It's always calming to see how many of us drift through these sleepy journeys together. And now, we'll ease back into the heart of tonight's topic. Earth's climate is shaped by subtle forces that shift slowly over thousands of years. Small changes in sunlight, gentle wobbles in Earth's rotation, and long, patient cycles in the oceans all play a role. These influences are delicate, never sudden, never forceful. They build gradually, like layers of soft snow collecting over time. And when these factors line up just right, the world cools, ice expands, and an ice age quietly begins its long sweep across the continents. The idea of a future ice age isn't something to fear. If it comes at all, it will come slowly, in rhythms so vast that countless generations would pass before the change became complete. In tonight's script, we'll explore possibilities, not predictions. We'll wander gently through scientific theories, ancient patterns, and soft mysteries that help us imagine how Earth's climate might shift again one day. So settle in, breathe softly, and allow your thoughts to drift like falling snow. We're about to explore the long, quiet history of Earth's ice ages and the dreamy question of when the next one might arrive. Long before humans walked the planet, long before forests spread across continents or oceans took their familiar shapes, Earth entered its very first ice ages. These ancient coolings unfolded so slowly and across such enormous spans of time that they feel almost like distant dreams rather than geological events. Scientists look back millions of years to trace these frozen eras, uncovering faint clues that reveal how calm and patient the planet's climate can be. Imagining these early ice ages helps create a sense of deep time, where the world shifts so gradually that entire landscapes rise and fall before a full cycle completes. The earliest ice ages occurred billions of years ago, during a period when Earth's atmosphere was very different from today. The sun shone more faintly then, giving the planet a cooler glow that may have encouraged long stretches of ice. Geological evidence suggests that continents were arranged differently. Oceans moved in unfamiliar patterns, and the atmosphere held simple gases that shaped the climate gently but profoundly. These early glaciations were quiet transformations, spreading slowly over regions that had not yet developed the life and structure we recognize now. One of the most mysterious ancient ice ages is sometimes called the Snowball Earth era. During this time, scientists believe that ice may have covered nearly the entire surface of the planet. Oceans froze from pole to equator, reflecting sunlight back into space and keeping Earth in a deep, cold stillness. But even this idea is softened by uncertainty. Some theories suggest the planet was only partially frozen. Others imagine pockets of open water shining through the ice. The true picture remains dreamy and elusive, shaped by fragments of evidence buried in ancient rocks. What we know for certain is that Earth passed through this time slowly, emerging from the frozen state with equal patience, like a world thawing from a long, quiet slumber. Later, ice ages arrived with calmer rhythms. As continents drifted into new arrangements, mountains rose and shaped the winds, and ocean currents shifted their slow paths across the globe. Earth's climate responded in gentle cycles. Glaciers advanced and retreated across the surface, carving valleys, shaping lakes, and smoothing landscapes over millions of years. These changes never came abruptly. They followed long, steady arcs where cooling took thousands of years to deepen and warming took thousands of years to fade. Each ice age left a signature in the rocks and sediments, recording its passage in soft, layered patterns. What makes these early cycles so intriguing is how many different theories attempt to explain them. Some scientists focus on Earth's orbit, how small variations in its shape and tilt could influence the amount of sunlight reaching the surface. Other theories look at the chemistry of the oceans, imagining how slow changes in carbon or oxygen might cool the atmosphere. Still, others explore volcanic activity, continental drift, or the gradual evolution of life itself, each offering a quiet clue to how the planet slipped into these frozen eras. None of these theories is complete on its own, but together they form a gentle mosaic of possibilities that invite us to imagine how many subtle forces shape Earth's climate. Even though these early ice ages feel distant, they help us understand the calm, repeating nature of Earth's climate cycles. They show that cooling is not something sudden or unpredictable. It is a slow movement influenced by rhythms that unfold over tens of thousands or millions of years. The planet shifts into these states the way a candle dims, softly, gradually, and with many steps along the way. Thinking about these ancient changes brings a sense of comfort, reminding us that Earth is guided by forces much larger than any moment in human time. As we drift through this script, each theory we explore will be framed in the same soft, speculative way. Possibilities shaped by evidence, imagination, and the quiet patterns of deep history. These early ice ages help set the stage, offering a glimpse into how Earth has changed before and how it might change again in far, far distant futures. When scientists look for patterns in Earth's long climate history, they often discover gentle rhythms that unfold over thousands of years. These rhythms, subtle and patient, help explain why ice ages come and go in cycles rather than as isolated events. The forces behind them are not loud or sudden. They are quiet influences, small changes in sunlight, tiny shifts in Earth's tilt, slow wobbles in its rotation that accumulate over deep stretches of time. When imagined softly, these cycles feel almost like the planet's breathing, expanding into warmth and contracting into cold with long, measured intervals. One of the most calming ideas in this area involves the shape of Earth's orbit. Over tens of thousands of years, Earth's path around the Sun becomes slightly more circular, then slightly more elongated, and then circular again. These changes are gentle, occurring so slowly that life on the surface never senses them directly, yet they influence how much sunlight reaches different parts of the planet. When Earth's orbit stretches outward, sunlight spreads more thinly across the seasons. When it returns to a rounder shape, light arrives more evenly. This cycle encourages long, slow shifts in temperature that can make ice ages more likely during certain periods. Another quiet rhythm involves the tilt of Earth's axis. Our planet leans slightly as it orbits the Sun, creating the familiar pattern of seasons. But over thousands of years, this tilt changes by a few degrees, drifting slowly between positions that shape how sunlight touches each hemisphere. A greater tilt brings warmer summers and colder winters, while a smaller tilt softens both extremes. These small changes, though subtle, can influence whether snow melts fully each year or whether it lingers, slowly accumulating into the seeds of future glaciers. Earth also wobbles gently as it spins. This wobble, called precession, shifts the timing of the seasons over many thousands of years. Summer sunlight may arrive at slightly different points in Earth's orbit, altering the length and warmth of seasons in ways too slow to notice in a single lifetime. But over long periods, this soft adjustment can encourage or discourage the growth of ice sheets, guiding the planet through its cooling and warming cycles like a slow, quiet metronome. Together, these three rhythms, orbital shape, axial tilt, and rotational wobble, form a set of long, overlapping cycles that influence Earth's climate. They are not the sole cause of ice ages, but they help set the stage. Some scientists compare them to gentle background music, shaping the emotional tone of a scene without being the scene itself. These cycles guide sunlight, tilt shadows, and create the soft timing that allows ice ages to expand and retreat with remarkable regularity. Other theories add subtle layers to this picture. The oceans, for example, store vast amounts of heat and release it slowly over time. Their currents shift in quiet patterns, carrying warmth from one region to another in ways that influence climate over centuries. When these currents change their flow even slightly, the global temperature can cool or warm in a slow, steady drift. Some theories imagine these ocean rhythms syncing gently with Earth's orbital cycles, creating moments when the planet becomes more receptive to long-term cooling. The atmosphere plays a delicate role as well. Variations in greenhouse gases, especially carbon dioxide, may rise and fall in step with ocean changes and biological activity. These fluctuations, though modest in ancient times, influenced how much heat the planet retained. Some theories propose that these gas levels responded to slow changes in sunlight or the advance of glaciers, forming self-reinforcing patterns that nudged Earth deeper into Ice Age conditions. Volcanic activity introduces another subtle possibility. Over thousands of years, eruptions release particles into the atmosphere that reflect sunlight. Although individual events fade quickly, long-term trends in volcanic activity may create gentle cooling pulses that add to the broader rhythms. These ideas remain speculative, but they offer soft hints of how interconnected Earth systems can be when shaping climate over vast timescales. What makes all these theories soothing is the sense of patience they convey. Earth's Ice Age cycles are not the result of anything fast or dramatic. They arise from a collection of gentle influences that build slowly, overlap softly, and guide the planet through transitions that take tens of thousands of years to complete. These rhythms remind us that Earth moves through deep cycles with calm regularity, shaped by forces that whisper rather than shout. All across Earth, gentle signs of past ice ages linger in the landscape, quiet reminders of eras when glaciers move slowly across the surface. These traces are not loud or dramatic. They are soft fingerprints of ancient ice, left behind in valleys, mountains, and plains that have settled into stillness over thousands of years. When imagined in a sleepy way, these features feel like echoes of long, cold breaths, patterns carved by slow, patient forces that shape the world in silence. One of the clearest signs appears in the shape of valleys. Glaciers carve the land differently from rivers. Rivers create narrow V-shaped paths, while glaciers, moving slowly and steadily over centuries, carve broad U-shaped valleys with smooth, rounded sides. Many such valleys rest quietly today, filled with forests, lakes, or farmland, holding the soft imprint of a glacier that drifted away long before humans ever arrived. These shapes remind scientists that ice once rested here, thick and heavy, advancing and retreating with the calm rhythm of deep time. Another trace lies in scattered boulders. In regions touched by glaciers, enormous rocks appear in places where no local geology can explain them. These erratic boulders were carried gently within the ice, held for thousands of years as the glacier drifted along its path. When the ice melted, the boulders settled softly onto the ground, left behind as quiet markers of a journey completed ages ago. Some stand alone in open fields, others rest along ridges or near lakes, offering silent hints of the glacier's long movement. Moraines, low ridges of rocks and soil, form when glaciers push material ahead of them like a slow-moving wave. When the glacier pauses or retreats, it leaves these ridges behind. Today, moraines appear as gentle hills, often covered in grasses or forests, their origin hidden unless one knows where to look. They stretch across landscapes like calm lines drawn by a patient hand, marking the edges of ancient ice. Lakes, too, carry the memory of ice ages. Many were carved by glaciers or formed when blocks of melting ice left depressions in the ground. These lakes fill quietly with water, becoming serene blue pools that reflect the sky. In places like Canada, Northern Europe, and parts of Asia, entire chains of lakes follow the paths of long-vanished glaciers, their shapes smoothed by ice that moved with slow persistence. Even the soil in many regions holds gentle hints of glacial pasts. As glaciers scrape the land, they ground rocks into fine particles. When the ice melted, these sediments settled into layers that later became fertile grounds for forests and fields. Farmers plow these soils today without realizing they are touching the delicate remnants of ancient ice, turned into soft earth by time and warmth. In mountain ranges, cirques offer another quiet sign. These bowl-shaped hollows formed where small glaciers once nestled, turning slowly and carving smooth depressions into the rock. Many cirques now cradle calm lakes or meadows, their icy origins softened into peaceful shapes by thousands of years of thawing and erosion. Imagining a glacier once resting in these hollows brings a gentle sense of connection to the past, as though the mountains carry quiet memories of colder days. Striations, thin, parallel scratches on rocks, add even finer details. These lines were etched by stones embedded in the base of a glacier as it moves slowly over the surface below. Today, the scratches appear as faint marks, easy to overlook but deeply meaningful. They show the exact direction the glacier once traveled, like delicate handwriting left behind by moving ice. Scientists studied these traces to understand how far ancient glaciers reached, how quickly they moved, and how long they stayed. But even without scientific purpose, imagining these features helps create a feeling of calm continuity. The ice came slowly, shaped the land gently, and faded away at a pace so patient that each change blended seamlessly into the next. The landscapes we see now carry the soft imprints of those long cycles, quiet reminders of how Earth shifts between warmth and cold, always moving at rhythms far slower than our own. These traces help set the mood for exploring the next ice age. They show that when Earth cools, it does so through processes that unfold steadily, sculpting the land in ways that persist long after the ice retreats. Each valley, ridge, lake, and boulder becomes part of a deep story, hinting at cycles that may one day return in far distant futures. To understand the timing of past ice ages, scientists often turn to some of the quietest clues on Earth. These clues are stored deep within frozen layers of ice and settled sediments at the bottom of ancient oceans. They hold delicate signatures of the planet's long climate history, soft records of temperatures, winds, and atmospheric changes that unfolded slowly across tens of thousands of years. When studied gently, these clues feel almost like whispered memories, preserved in fragile layers that drift backward through time. Ice cores are among the clearest of these quiet records. In Greenland, Antarctica, and other frozen regions, thick sheets of ice have built up layer by layer over hundreds of thousands of years. Each winter, snowfall compresses beneath the next, trapping tiny bubbles of ancient air as it solidifies. These bubbles hold the atmosphere exactly as it existed long ago, preserving faint traces of gases and particles that reveal how warm or cold the world was at the time. Scientists drill carefully into the ice, pulling out long cylinders that resemble pale blue timelines. When they examine these cores, they can see periods of cooling and warming expressed as gentle variations in the trapped air. The beauty of ice cores is their stillness. Once a layer forms, it remains undisturbed for ages. Dust from distant deserts, salt from ocean spray, and tiny fragments of volcanic ash settle into the ice, leaving subtle markers that help scientists understand the rhythm of past climates. These layers build a quiet picture of each ice age. When it began, how intensely it cooled, and how slowly it lifted. When imagined softly, an ice core becomes like a frozen diary of Earth's atmosphere, written in calm, delicate strokes across deep time. Ocean sediments tell another part of the story. At the bottom of the sea, particles drift slowly to the ocean floor. Tiny marine organisms live and die, leaving behind shells made of minerals that reflect the temperature and chemistry of the waters they lived in. As these shells settle, they form thin layers of sediment, each capturing a moment in the ocean's long memory. Over millions of years, these layers accumulate into thick sequences that scientists can analyze. The ratios of oxygen within the shells, for example, shift gently with global temperature, revealing warm and cool periods in a pattern as steady as a heartbeat. The combination of ice and ocean records creates a soft, synchronized portrait of Earth's ice age cycles. When scientists overlay these clues, they find strong alignment. Periods of cooling appear in both the ice and the sea, confirming that global temperatures rose and fell together. The rhythm is unmistakable, a repeating pattern shaped by gentle changes in sunlight, slow shifts in greenhouse gases, and the gradual influence of ocean currents. Some cycles last around 100,000 years, while others follow shorter or longer beats. All of them blend into a soothing sequence that reflects the planet's deep, patient climate voice. Dust provides yet another quiet clue. During colder periods, deserts expand and winds grow slightly stronger, carrying fine grains of dust into the atmosphere. When an ice age begins, this dust becomes more common in both ice cores and ocean layers. It settles gently across the world, leaving behind faint signals that help scientists understand when glaciers were growing and when they were retreating. The presence of dust is subtle, almost invisible, yet it stands as one of the clearest markers of the planet cooling into an ice age state. In some ice cores, researchers even find tiny pieces of pollen from ancient plants. These fragments reveal which vegetation dominated during colder centuries, offering soft glimpses into landscapes long vanished. Forests shrank during intense cooling. Grasslands spread. Tundra plants drifted southward as glaciers advanced. These quiet plant signals help complete the picture, tying climate changes to the living world and showing how ecosystems responded gently, adapting at the slow pace set by Earth's cooling rhythms. These combined records, ice, sediments, dust, and pollen, create a calming sense of continuity. They show that Earth's ice age cycles were not abrupt. They did not begin with sudden storms or dramatic shifts. Instead, they formed through delicate changes in heat, light, and circulation that built gradually over thousands of years. Imagining these processes brings a peaceful awareness of how slowly the planet moves through its long climate story, guided by rhythms far older and deeper than anything we experience today. And as we gather these clues, we discover hints about potential future coolings as well, not predictions, but suggestions. Quiet possibilities that echo patterns seen many times before, waiting somewhere in the distant reaches of Earth's unfolding time. If Earth's climate has a heartbeat, the oceans are part of its slow, steady rhythm. They hold immense amounts of heat, move it across the globe in quiet currents, and release it back into the atmosphere with a patient consistency that shapes long-term climate patterns. When imagining how ice ages begin and end, the oceans become a calm, guiding force, never abrupt, never loud, but influencing everything through deep, slow movements that unfold over centuries. One of the softest, yet most powerful ocean patterns is the global conveyor belt, a vast circulation that moves warm and cold water around the planet. Warm water drifts toward the poles, releasing heat into the cooler air, while cold water sinks and travels back toward the equator in a slow, deep current. This cycle takes hundreds, even thousands of years to complete. During Ice Age periods, this conveyor often changes its pace. Sometimes it slows, allowing more cold to settle across the northern oceans. Other times, it shifts its route slightly, guiding warmth into new regions. These changes are gentle, but over long timescales, they may help encourage the growth or retreat of ice. The North Atlantic plays a special role in this quiet story. When surface waters are here cool and become saltier, they sink more easily, strengthening the ocean's deep currents. Some theories propose that during the approach of an ice age, this sinking process becomes more active, pulling heat away from the northern hemisphere and sending it deeper into the sea. The atmosphere above cools gradually, allowing snow to linger longer each year. These subtle changes, repeating over centuries, may help glaciers take root. Other theories suggest the opposite, that meltwater from shrinking glaciers can freshen the ocean's surface, slowing the deep currents and cooling the region in a different way. Both ideas are soft possibilities, offering pathways by which oceans might guide Earth into colder climates. Farther south, the Antarctic plays its own quiet part. Here, cold water sinks around the edges of the continent, creating one of the most stable and continuous ocean currents on Earth. This circumpolar flow acts like a moving boundary, separating warmer waters to the north from the icy interior. During ice ages, this current may strengthen or weaken slightly, affecting how heat circulates between the hemispheres. These changes are not sudden. They whisper through the oceans with delays so long that no single generation would ever notice them. Deep ocean sediments capture the memory of these adjustments, Layers rich in certain minerals or tiny organisms reveal times when waters were cooler, warmer, or mixed differently. Scientists study these sequences to follow the ocean's long, rhythmic breathing. They find that during Ice Age transitions, ocean temperatures shifted gently, never in sharp spikes, but in long, gradual slopes that might extend for thousands of years. These smooth curves help explain why ice ages feel like slow chapters in Earth's climate story, rather than quick events. The oceans also interact with the atmosphere through gentle exchanges of carbon dioxide. Cold water absorbs more of this gas, while warm water releases it. Over long timescales, this exchange can influence global temperatures. Some theories propose that as oceans cooled at the start of an ice age, they absorbed more carbon dioxide, gently lowering atmospheric levels. This small change, repeated over centuries, contributed to the cooling trend. Later, as warming began, the reverse occurred. The oceans released more carbon dioxide back into the air, amplifying the gradual shift toward a warmer climate. Each step was slow, patient, and balanced. A quiet conversation between water and air. Another calming influence is the seasonal layering of the ocean itself. In warmer periods, the upper layers stay separate from the cold depths below, creating a gentle cap that limits mixing. During cooler phases, this layering weakens, allowing cold and warm waters to blend more freely. This mixing affects the movement of nutrients and gases, shaping life in the oceans and influencing how the planet stores heat. These patterns shift slowly, guided by small changes in sunlight and the planet's orbit, creating long-term trends that echo through the climate system. When we imagine the ocean's role in ice ages, it feels less like a cause and more like a companion, one that responds gradually to changes in sunlight, wind, and temperature, and then reinforces those changes with its own slow motions. It is a system that remembers. It holds warmth or releases it, carries signals across great distances, and shapes climate in ways that feel both mysterious and deeply soothing. This quiet interplay between ocean and atmosphere reminds us that Earth's climate is never shaped by a single force. It is a tapestry woven from countless slow threads, each contributing softly to the cycles that guide the planet through ice ages and warm periods. And as we drift deeper into our exploration, we'll begin to see how these threads intertwine, how oceans, sunlight, winds, and ice work together to form the gentle rhythms that define Earth's long climate story. While oceans guide the planet's slow movements of heat, the atmosphere adds its own soft layer of influence to ice age cycles. It may seem too delicate, too thin and airy to shape something as vast as a global freeze, but over thousands of years, the atmosphere responds to subtle changes in sunlight, temperature, and circulation in ways that gradually encourage cooling or warming. Imagining the atmosphere as a quiet, shifting veil around the planet helps us understand how ice ages form through gentle, intertwined processes rather than sudden events. One of the most calming ideas involves greenhouse gases, especially carbon dioxide. In Earth's ancient climate, levels of these gases rose and fell softly, influenced by volcanic emissions, plant life, ocean absorption, and long chemical cycles in rocks and soils. During colder phases, carbon dioxide levels tended to drift lower, allowing more of Earth's heat to radiate back into space. This was not a sharp drop. Instead, it unfolded across centuries, creating a slow, steady tilt toward cooler conditions. When warming began, levels climbed again just as gradually, helping the planet ease out of its icy state. These cycles behaved like subtle feedback loops, gentle reinforcements that strengthened trends already shaped by orbital rhythms and ocean patterns. Water vapor, another quiet component of the atmosphere, also played a role. Because colder air holds less moisture, Ice Age climates tended to be drier, with smaller amounts of vapor to trap heat near the surface. This delicate reduction helped cooling continue, encouraging snow to linger longer each year. Over time, as white surfaces expanded, they reflected more sunlight, adding to the soft downward drift in temperature. Scientists refer to this as the albedo effect, and though it can amplify cooling, it does so in a way that feels gradual and patient, like a slow spreading of frost across a window. Winds changed rhythm during ice ages as well. As temperatures dropped, atmospheric circulation patterns shifted slightly, guiding storms along different paths and altering the distribution of snow and ice. These changes were subtle but cumulative. More snow falling in regions where summers were too cool to melt. It meant that glaciers could grow quietly year by year. The atmosphere carried these snowflakes gently, transporting moisture from oceans to land in patterns that slowly shaped the advance of ice sheets. Dust also interacted with the atmosphere in a fascinating way. During colder periods, stronger winds over expanding dry regions lifted fine particles into the air. This dust settled on ice sheets, darkening their surfaces and allowing them to absorb slightly more heat. Paradoxically, this could slow the growth of glaciers in some areas or shape their edges in soft, uneven ways. Dust in the atmosphere also reflected sunlight before it reached the surface, adding another delicate influence to the planet's cooling cycle. These interactions were not dramatic. They were quiet, balancing effects that helped guide the pacing of Ice Age transitions. Clouds contributed their own gentle complexities. Depending on their height, thickness, and composition, clouds could either warm or cool the planet. During Ice Ages, cloud patterns may have shifted subtly, influenced by colder oceans, drier air, and the growing presence of ice. Some theories suggest that cloud cover increased slightly during glacial periods, reflecting more sunlight back into space. Others imagine changes in nighttime cloudiness that allowed more heat to escape into the dark. These effects, though small on their own, blended into the slow rhythm of cooling that deepened Ice Age conditions. Another soft theory involves atmospheric circulation cells, the large-scale patterns that guide air across the planet. As temperatures shifted, these cells may have expanded, contracted, or migrated slightly, altering wind belts and gently repositioning regions of rising and sinking air. These changes influenced where storms formed, where rain fell, and how snow accumulated, helping shape the broader landscape of cooling. Scientists still explore these patterns with curiosity, knowing that the atmosphere's behavior during past ice ages holds many quiet mysteries. Perhaps the most soothing aspect of the atmosphere's role is its connectedness. It does not act alone. Every shift in wind or moisture is tied to the oceans, the land, the ice, and the sunlight that moves across Earth each day. The atmosphere is the responsive layer, adjusting gently to deeper forces that unfold beneath it. Its patterns reflect the combined influences of orbital rhythms, ocean currents, and surface changes, weaving them into a soft, ever-changing tapestry that helps guide the planet's long climate cycles. As we imagine these atmospheric influences, we see how ice ages are shaped by the quiet interplay of many subtle forces. Cooling is never driven by a single event. It is the result of small changes accumulating softly across thousands of years, each one reinforcing the next with calm persistence. And within this slow movement, the atmosphere drifts like a delicate veil, sometimes warming, sometimes cooling, always responding with gentle flexibility to the deep rhythms of Earth's past and future climates. When imagining ice ages, it's easy to picture glaciers as static blocks of frozen water. But in reality, ice sheets move, slowly, gently, and with a quiet persistence that reshapes entire continents. Their motion is almost imperceptible from day to day, yet across thousands of years, these sheets drift forward, spread outward, and retreat in long, drawn-out rhythms that feel more like geological breathing than physical movement. Understanding their behavior provides another soft clue to how ice ages unfold and how Earth shifts between frozen eras and warmer periods. Ice sheets begin with snow that lingers through the summer. When year after year of snowfall remains unmelted, the layers stack, compress, and turn gradually into glacial ice. This transformation is calm and steady, taking decades or centuries. As weight builds, the ice begins a slow journey outward, flowing under its own pressure. The movement is so gradual that glaciers may advance only a few centimeters a day, sometimes less. Yet over long stretches of time, this gentle push becomes powerful enough to carve landscapes, carry rocks, and alter coastlines. During past ice ages, enormous ice sheets covered much of North America, Northern Europe, and Siberia. These massive frozen expanses thickened until they stood several kilometers tall, resting across the continents like a vast, shimmering blanket. Their weight pressed into the Earth's crust, depressing the land beneath. This deep, patient force reshaped entire regions, lowering valleys and creating basins that later filled with lakes. Wherever the ice passed, it left behind a softened landscape, smoothed rock surfaces, rounded hills, and quiet plains formed by centuries of gentle grinding. One of the most calming aspects of glacial movement is its consistency. Ice sheets do not surge unpredictably. They respond slowly to temperature changes, snowfall patterns, and subtle shifts in sunlight. When cooler conditions persist, the ice thickens and advances. When warmer conditions return, melting begins and the ice retreats. This ebb and flow can span tens of thousands of years, creating a peaceful, repeating pattern of expansion and contraction that mirrors the larger ice age cycles. The edges of ice sheets hold their own quiet mysteries. As glaciers advance, they push soil, rocks, and debris outward, forming moraines that mark their former boundaries. These ridges remain long after the ice disappears, stretched gently across the landscape as reminders of frozen eras. In some places, meltwater from the ice carved deep channels or formed braided rivers that shifted slowly over time. These features give scientists hints about how quickly the ice moved and how long it lingered in each region. Beneath the ice, a hidden world exists. Pressure from the ice sheet can melt the bottom layers, creating thin films of water that allow the glacier to slide more easily. This water flows in quiet, dark channels, carrying sediments and shaping the landscape beneath the surface. The interplay between ice and meltwater is delicate. Just a slight increase in warmth can change the flow, speed, or thickness of the glacier's movement. Over thousands of years, these gentle adjustments help determine how far the ice spreads and how deeply it carves the ground. Another soft influence involves the feedback between ice and light. As ice expands, it reflects more sunlight into space, encouraging further cooling. This reflective quality, part of the albedo effect, reinforces ice age conditions with quiet persistence. The more the ice grows, the more sunlight it sends away, allowing cooling to continue. This feedback doesn't act suddenly. It's a slow amplification of trends already underway, like a whisper repeating itself until it becomes a soft chorus, guiding the climate toward deeper cold. When the planet begins to warm again, ice sheets retreat with the same gentle patience. Melting at the edges creates lakes and rivers that flow outward in wide, calm patterns. As the weight of the ice lifts, the land beneath slowly rebounds, rising upward in a process that can take thousands of years. Forests return, soils form, and ecosystems fill the spaces where ice once rested thick and still. The transition from glacial to interglacial periods is not abrupt. It unfolds like the slow unfolding of a long winter into spring. These glacial movements remind us that ice ages are not defined by sudden shifts. They are shaped by the quiet persistence of ice, responding gradually to the deep rhythms of Earth's orbit and atmosphere. Each expansion and retreat tells a story written in slow motion, a story that stretches across landscapes and through time with calm regularity. Imagining these processes helps us understand how gentle the onset of an ice age truly is, and how similarly gentle its departure can be. When scientists study the history of ice ages, a soft pattern emerges, one that stretches across hundreds of thousands of years and repeats with the calm regularity of a distant geological clock. These cycles are not perfect or precise, but they carry a recognizable rhythm, shaped by slow changes in sunlight, subtle atmospheric shifts, and the long breathing of the oceans. Imagining this rhythm helps us understand how ice ages fit into Earth's deeper memory, and why the planet moves gently between cold and warm periods. With such timeless patience, during the last few million years, ice ages have tended to follow a repeating interval of roughly 100,000 years. This is not a rigid schedule, but a broad, lingering pattern, with each cycle unfolding differently from the last. Some ice ages lasted longer, while others arrived more quickly or ended sooner. Yet when viewed from afar, the pattern holds a soothing consistency. Cool periods deepen slowly, last tens of thousands of years, and then ease into warmer interglacials that persist until the cycle begins again. These transitions resemble long, overlapping waves drifting across the planet's climate. The last major ice age reached its coldest point about 20,000 years ago, when massive glaciers covered much of the northern hemisphere. Since then, Earth has been in a warmer interglacial period, one of many that have come and gone throughout the planet's history. When viewed softly, this warm era feels like a gentle pause between long exhalations of ice. The climate has been stable, allowing forests, grasslands, and oceans to settle into familiar rhythms. This interglacial, known as the Holocene, is the quiet space we occupy now, one that began about 11,000 years ago and continues to shape the world around us. Scientists piece together the timing of these cycles using ice cores, ocean sediments, and ancient landscapes. The patterns they find align closely with the variations in Earth's orbit and axial tilt. These orbital rhythms stretch across scales of 20, 40, and 100,000 years, creating soft pulses that influence how much sunlight reaches the planet. When these pulses align in certain ways, cooling becomes more likely. When they shift again, warming follows. Nothing in these patterns is abrupt. The climate responds slowly, like a vast instrument resonating with deep, quiet vibrations. Some theories propose that ice age timing also depends on the internal rhythms of the climate system itself. As ice sheets grow, they reach sizes that make further expansion easier. Their reflective surfaces cool the planet, reinforcing the trend. Over time, however, the glaciers become so large that small increases in sunlight or small changes in circulation create tipping points that encourage retreat. This relationship behaves like a gentle seesaw, balancing ice growth and ice melt over long spans. The timing of each ice age may reflect this slow balancing act, where the system moves through cycles defined not only by external forces, but by its own quiet tendencies. Another idea suggests that ice ages follow patterns guided by the oceans. When deep ocean temperatures shift, they affect how much heat the planet retains. These changes can take thousands of years to ripple through the climate system. If a cooling trend begins during a period when ocean currents favor additional cooling, the ice age may deepen more quickly. If a warming trend begins when ocean currents bring heat northward, the retreat may accelerate. These interactions remind us that the timing of ice ages is not the result of a single mechanism, but the merging of many slow influences, each contributing softly to the direction of the planet's climate. Dust records offer additional clues. During glacial periods, dust concentrations in ice cores rise slowly, signaling colder, drier conditions. When Earth warms, dust levels fall. These gradual shifts help scientists mark the beginning and end of ice ages with surprising clarity. Imagining these dust layers creates a sense of gentle progression, as if the planet marks its own climate chapters with faint strokes of wind-blown particles. What makes the timing of ice ages so soothing to contemplate is the scale of it all. These cycles are vast, stretching far beyond the span of human existence. No individual lifetime can perceive their beginning or end. Even entire civilizations rise and fall within the quiet space of an interglacial. This immense scale creates a sense of calm distance, reminding us that the planet moves at a pace much slower than our day-to-day experiences. Understanding this timing helps frame the question of future ice ages, not as something imminent or abrupt, but as a distant possibility unfolding along the same gentle rhythms that guided the planet for millions of years. The next ice age, if it comes, will follow this slow pattern, shaped by forces that build quietly across thousands of years. And as we explore theories about that distant future, the soft timing of the past will guide our imagination with the same calm certainty it has always carried. One of the softest yet most influential guides of Earth's long cooling cycles is sunlight itself. Not sunlight in the everyday sense, the warm glow that brightens mornings and softens evenings, but the slow, subtle variations in how that light reaches different parts of the planet over thousands of years. These quiet changes are shaped by Earth's orbit, its tilt, and the timing of its seasons, creating gentle rhythms that help determine when the planet drifts toward an ice age and when it eases back into warmth. Imagining these variations feels like watching light move across a room throughout the day, soft, gradual, and endlessly patient. During certain orbital configurations, the northern hemisphere receives slightly less summer sunlight. The change is small, far too subtle to notice within a single lifetime, but over long stretches of time, these gentler summers allow more snow to linger through the warm season. Each year, a thin layer remains unmelted. Over centuries, the snow compacts into ice, and over millennia, these patches grow into glaciers. This slow accumulation sets the stage for the expansion of ice sheets, creating one of the foundational rhythms behind Earth's ice age cycles. The tilt of Earth's axis contributes another layer to this delicate dance. When the planet tilts more steeply, seasons become stronger, summers warmer, winters colder. When the tilt becomes smaller, seasons gentle themselves, creating cooler summers that favor the persistence of snow. This shift in tilt happens gradually over tens of thousands of years, shaping the planet's climate in soft pulses. Some theories suggest that ice ages begin most easily when the tilt is minimal, and sunlight arrives at higher latitudes in softer, cooler angles. Earth's gradual wobble, its precession, adds another quiet influence. Over long cycles, this wobble changes the timing of the seasons relative to Earth's position in its orbit. Sometimes, the northern hemisphere's summer occurs when Earth is farther from the sun. Sometimes, summer arrives when Earth is closer. The difference is subtle, but over long timescales it gently alters how much heat the planet receives during the season that determines whether snow melts or remains. When these orbital factors, distance, tilt, and wobble, align in certain ways, they blend into a soft configuration that encourages the formation of ice. The remarkable thing about these variations is how small they are. They do not drastically change the total amount of sunlight Earth receives in a year. Instead, they redistribute the sunlight's warmth in delicate patterns across seasons and latitudes. These small redistributions influence snow cover, sea ice, ocean circulation, and even atmospheric moisture. Each change is soft and cumulative, building slowly until the planet settles into a cooler state. Some scientists describe these orbital cycles as the quiet pacemakers of the ice ages, setting the tempo for glacial and interglacial transitions that unfold over tens of thousands of years. During past ice ages, the sun's gentle variations aligned with other climate factors. Changes in greenhouse gases, shifts in ocean currents, and alterations in atmospheric patterns. These combined effects amplified cooling, but always with the same patience. Glaciers did not surge forward abruptly. They expanded softly, responding gradually to the interplay of sunlight and surface conditions. When the orbital cycle shifted again, sunlight returned to northern latitudes with slightly more strength. Summers grew longer and warmer. Snow melted more effectively. Glaciers retreated in slow arcs, giving way to forests, rivers, and lakes that emerged over thousands of years. Ice cores reveal this interaction with extraordinary clarity. Peaks and valleys in ancient temperatures often line up with changes in solar geometry, creating a calm, repeating pattern across hundreds of thousands of years. Scientists do not view sunlight alone as the cause of ice ages, but as a guiding influence, one that tunes the climate system, encouraging cooling when conditions align and allowing warmth to return when the cycles shift again. Some theories even propose that minor changes in solar output, tiny fluctuations in the sun's brightness, may add a faint, additional nudge to Earth's climate rhythms. These variations are small enough to be nearly imperceptible, yet gentle enough to play a supporting role in long-term cooling or warming. Whether or not these solar fluctuations significantly affect ice age timing remains a soft mystery, one that scientists continue to explore through quiet observations of both modern and ancient sunlight. What makes the relationship between sunlight and ice so soothing to imagine is its graceful consistency. Nothing in this dance is sudden. The planet responds slowly to subtle shifts in the angle of light, the timing of seasons, and the long arc of its orbit. These slow changes remind us that Earth's climate is shaped not by abrupt forces, but by gentle, overlapping rhythms that unfold at a pace far beyond human experience. And in imagining these rhythms, we gain a calm understanding of how ice ages begin, not with dramatic darkness or sudden cold, but with soft variations in sunlight that whisper across thousands of years, guiding the climate into its next long, quiet chapter. Once cooling begins on Earth, a series of gentle feedback loops can help guide the planet deeper into an ice age. These loops are not forceful mechanisms. They are soft reinforcements, tiny adjustments that accumulate slowly, nudging the climate toward colder conditions over thousands of years. Each loop interacts with others in calm, interwoven ways, creating a layered effect that deepens the long glacial phases of Earth's climate history. Imagining these loops feels like watching ripples spread across still water, each one subtle but meaningful as it blends into the next. One of the most soothing feedbacks involves snow and ice expanding across the surface. Ice reflects sunlight efficiently, sending much of the incoming energy back out into space. As the planet cools slightly and ice spreads, more sunlight is reflected away. This encourages further cooling, which allows more ice to form. The cycle grows gradually stronger, like a soft echo building upon itself. Scientists call this the ice albedo feedback, and it is one of the gentle engines that help ice ages settle more deeply into place. Another calm feedback involves the atmosphere's moisture. As temperatures drop, the air holds less water vapor. Water vapor is a natural greenhouse gas, so when its levels decrease, the planet loses a small amount of its insulation. This subtle reduction allows more heat to escape into space, reinforcing the cooling that began from orbital shifts or ocean changes. This feedback loop unfolds so slowly that it becomes almost invisible on a human timescale. Yet across thousands of years, it plays a meaningful role in guiding Earth into glacial conditions. The oceans, too, provide layered feedback. Cold water absorbs more carbon dioxide from the atmosphere, causing greenhouse gas levels to decline gently. As the oceans pull carbon dioxide from the air, cooling deepens, reinforcing the cycle. Over centuries, this process becomes a quiet, stabilizing influence on Ice Age conditions. Later, during warming phases, the oceans release some of this stored carbon dioxide back into the atmosphere, supporting a slow transition out of glacial periods. These exchanges are soft, patient, and perfectly aligned with the long rhythms of Earth's climate. Vegetation adds its own delicate touch to these cycles. During cooler periods, forests retreat from the far north, replaced by open tundra and grasslands that reflect slightly more sunlight. This shift in land cover contributes to cooling in a faint, supplementary way. Plants also influence how carbon moves through the atmosphere and soil. As ecosystems shrink or expand, they alter the balance of carbon stored in living tissues and released into the air. These changes never drive the climate on their own, but weave into the broader tapestry of feedbacks that support glacial expansion. Dust patterns offer another subtle feedback. During ice ages, the planet becomes slightly drier and windier in certain regions, lifting more dust into the atmosphere. This dust reflects some sunlight, contributing to further cooling. When dust settles onto ice sheets, it can slightly reduce their reflectivity, adding a small warming influence. These opposing effects blend into a quiet, shifting balance that shapes the edges of glacial cycles. Scientists study dust layers carefully because they track these feedbacks with unexpected clarity, offering insights into how softly the climate system responds to broader changes. Ocean circulation shifts provide deeper, slower feedback loops. As ice sheets grow, sea levels drop, exposing continental shelves and altering coastlines. These changes influence ocean currents, which then adjust the distribution of heat around the globe. A small cooling in one region may lead to a slight slowdown in a major current, causing more cooling in another region. Over time, these subtle changes reinforce one another, helping the planet settle into a fully glacial state. Nothing in these adjustments is abrupt. They move like gentle, unseen tides, shaping climate patterns in long, whispered motions. Even the ice sheets themselves participate in feedback. As they thicken, their height lifts them into colder layers of the atmosphere, slowing melt at the surface and allowing even more snow to accumulate. Their weight presses the land downward, influencing regional climates and shaping patterns of wind and moisture. These changes remain quiet, unfolding across centuries, yet together they help maintain the stability of glacial conditions. What makes these feedback loops especially soothing to imagine is how interconnected they are. No single loop controls the climate. Instead, each one adds a soft influence. reinforcing cooling in a slow, patient manner. These loops respond gently to orbital cycles, sunlight variations, and changes in ocean temperatures. They behave like background harmony supporting the main melody of Earth's climate rhythms. Understanding these feedbacks helps us appreciate the elegance of ice ages. They are not sudden winters imposed upon the world. They are the result of countless small influences, each contributing quietly to a greater whole. And as we continue exploring theories about future ice ages, these soft loops remind us that Earth's climate responds to change in gradual, almost meditative ways, moving slowly through cycles that unfold across vast stretches of time. An ice age never begins with a dramatic shift. It doesn't announce itself with sudden cold or sweeping changes. Instead, it starts quietly, with small variations that gather gently over thousands of years. The earliest stages are so subtle that no single moment stands out. The planet simply moves into a slightly cooler pattern, almost imperceptible from one generation to the next. Like a long breath, the Earth slowly exhales. Even imagining this beginning feels peaceful, as though the world is settling under a faint, drifting layer of calm. The first hint of cooling often begins in the high latitudes, where snow arrives a little earlier in the year and lingers a little longer. The cold seasons grow just slightly gentler in their warmth and heavier in their stillness. Each year, a delicate layer of snow survives the summer melt, only a thin sheet at first, hardly noticeable. But over centuries, these lingering layers of snow accumulate and begin to compact into ice that settles into the landscape. Nothing feels sudden or forceful. The world simply shifts into a quieter rhythm, letting new patterns settle in. As the climate cools, the oceans respond in soft, patient ways. Surface waters become slightly cooler, and currents adjust their flow. With these changes, the air carries a little less moisture, creating a subtle dryness in certain regions. This dryness encourages more snow to remain frozen through the warm season. A soft feedback emerges, one that builds upon itself with quiet persistence. The cooling of the oceans encourages the cooling of the land, and the cooling of the land encourages the growth of ice. All of it unfolds slowly, like gentle ripples extending across a calm surface. In the atmosphere, delicate shifts begin to take place. Winds move differently, circling the globe with patterns that favor cooler temperatures. Storms lose some of their warmth, releasing softer snow instead of heavy rain. These subtle changes create a world that feels slightly more muted, more reflective, more receptive to the long cooling that is quietly settling in. Even the air grows clearer, allowing more sunlight to be reflected off expanding fields of snow. The planet becomes a little brighter, a little more luminous, as ice begins to spread. The land responds in equally gentle ways. Forests retreat slowly from northern edges, giving way to open plains where grasses sway in colder winds. These shifts in vegetation take centuries, yet each change adds to the cooling atmosphere. Lighter ground reflects more sunlight. Snow settles more easily. The balance of warmth adjusts itself softly. These new landscapes help guide the world further into its cooling rhythm, supporting the quiet buildup of ice across wide stretches of land. During these early stages, the world remains vibrant. animals roam across landscapes that still feel familiar. Seasons continue to turn, rivers run freely. The early beginnings of an ice age are not dramatic or harsh. They are simply slower, softer, slightly cooler versions of the patterns that came before. Life moves at its usual pace, while the planet drifts, almost imperceptibly, toward a new climatic chapter. Glaciers begin to form only after long periods of gentle accumulation. Small pockets of persistent ice appear in high-altitude regions, then expand into valleys, then stretch outward across distant plains. These formations grow quietly, their movement measured in inches each year. Their presence becomes part of the landscape, reflecting sunlight and reshaping the air around them. Over time, the glaciers influence the world with their cool, steady presence, drawing the planet deeper into its glacial rhythm. One of the most soothing aspects of these beginnings is how evenly they unfold. No single force dominates. Instead, many soft changes overlap and reinforce one another. Slightly cooler summers, slightly longer winters, slight changes in ocean temperature, slight shifts in wind. Each influence is gentle on its own, but together they weave a quiet pattern that helps guide the planet into its long, icy phase. Even the timing of these early changes feels peaceful. An ice age does not rush. It emerges over tens of thousands of years, giving the world ample time to adjust. The planet settles into this new rhythm slowly, allowing each gentle shift to blend into the next. By the time the cooling becomes noticeable, the foundations have already formed through centuries of gradual change. Imagining the onset of an ice age in this soft, drifting way reminds us that Earth's climate is shaped by long, natural cycles that unfold with immense patience. The early steps are quiet, steady, and almost serene. And in these soft beginnings, the seeds of a future ice age take root, guiding the world toward one of its most mysterious and enduring transformations. As we drift deeper into the mystery of Earth's long cooling cycles, scientists have proposed many gentle theories about what triggers an ice age to begin. None of these ideas act alone, and none provide a sudden explanation. Instead, they create a soft collection of possibilities, each offering a quiet influence that might nudge the planet toward colder conditions over vast stretches of time. Imagining these theories feels less like solving a single puzzle, and more like exploring a landscape of subtle hints, each one pointing to a different aspect of Earth's deep climate rhythm. One of the most widely known ideas involves Earth's orbital cycles, which shift softly over thousands of years. When the northern hemisphere receives slightly less summer sunlight, ice has a better chance of lingering. This lingering snow accumulates gradually, setting the stage for glacial growth. Scientists suggest that these orbital patterns might be the initial whisper that begins the slide toward an ice age, though the whisper alone is too faint to carry the planet fully into a frozen state. It needs companions, other gentle forces that amplify the cooling. Ocean currents offer another theory. When currents shift their paths, even slightly, they can alter the distribution of heat across the planet. A small slowdown in a major current may encourage cold to linger in certain regions, while warm waters are carried elsewhere. Over hundreds of years, this can create conditions where snow persists longer, sea ice forms more readily, and glaciers find a stable foothold. Some theories suggest that the oceans might act as the silent gatekeepers of ice ages, initiating or delaying cooling through slow, unseen adjustments. Volcanoes introduce an intriguing possibility. Large volcanic eruptions release particles into the atmosphere that reflect sunlight. While individual eruptions cool the climate only for a few years, a long-term pattern of increased volcanic activity could, in theory, tilt the balance slightly toward cooler temperatures. Over thousands of years, this gentle dimming may add up, helping reinforce the faint signals from orbital cycles. This idea remains speculative, but it adds another delicate thread to the tapestry of Ice Age theory. Changes in Earth's magnetic field provide another soft curiosity. Some scientists wonder whether shifts in the magnetic field could influence atmospheric circulation or alter the way particles interact with sunlight. These effects would be extremely subtle, but across long periods, they might shape the climate in small, cumulative ways. This theory is not widely accepted, but it lingers as a quiet question, a reminder that Earth's deep systems are still filled with mysteries. Biological changes contribute additional possibilities. As forests expand or retreat, they influence how much sunlight the land reflects and how much carbon the atmosphere contains. During certain periods, vast regions of vegetation may have changed their distribution, gently shifting the balance between warming and cooling. These ecological transitions unfold slowly, taking centuries or millennia, yet they may play a quiet role in easing the planet into a glacial state. Some theories look to the chemistry of the oceans themselves. Changes in nutrient availability, marine organisms, or deep-sea carbon storage may influence the atmosphere in soft, long-term ways. If the oceans begin to absorb more carbon dioxide, cooling may gain momentum. If they release more, the opposite may occur. The interplay between ocean chemistry and atmospheric temperature is one of the planet's most delicate relationships, full of subtle feedbacks and gradual adjustments. Shifts in land masses and mountain ranges create more speculative possibilities. As continents drift slowly across the globe, their positions influence how sunlight is absorbed, how winds move, and how ocean currents flow. Even the rise of a mountain range can alter climate patterns by redirecting storms or creating cooler, high-altitude regions where snow accumulates more easily. Over millions of years, these geographic changes may help predispose the planet to certain cooling phases, making ice ages more likely when other factors align. There are even theories that look beyond Earth to the broader cosmic environment. Some researchers have explored the idea that changes in the solar system's position within the galaxy might influence how cosmic rays interact with the atmosphere. These interactions could affect cloud formation in faint, indirect ways. While this idea remains highly speculative and unconfirmed, it adds a dreamy layer of mystery to the question, reminding us that Earth's climate is shaped by forces both near and unimaginably far. What ties all of these theories together is their softness. None of them describe a dramatic cause. Instead, they outline subtle influences that blend over long timescales. Ice ages likely begin not because of any single trigger, but because many gentle factors align: orbital rhythms, ocean flows, atmospheric shifts, and geological patterns, all moving in quiet harmony. These ideas help us see ice ages as the product of Earth's natural balance, guided by slow forces that unfold with deep patience, shaping the planet in ways as mysterious as they are serene. When we imagine the distant future of Earth's climate, it's natural to wonder how another ice age might one day begin, not in a dramatic or alarming sense, but in the same slow, patient rhythm that guided ice cycles for millions of years. The possibilities are soft and far away, shaped by gentle shifts that would unfold over tens of thousands of years. Scientists explore these paths not to predict an exact future, but to understand how the planet might someday follow the same quiet patterns it has many times before. When imagined in a sleepy, drifting way, these theories feel like calm doorways into a distant chapter of Earth's story. One of the calmest paths involves the long rhythms of Earth's orbit. As the planet continues its ancient cycles, its tilt adjusting, its wobble shifting, its orbit stretching into new shapes, the amount of sunlight reaching northern summers will slowly change. If those summers become slightly cooler over thousands of years, snow in high latitudes may begin to linger longer than before. That lingering snow could become the earliest whisper of glacial growth. This possibility is neither sudden nor certain. It is simply one path, guided by the slow geometry of Earth's motion through space. Another path involves the oceans. Over long periods, ocean currents naturally shift their patterns, carrying warm and cold water along new routes. If, far in the future, deep currents began storing more heat in the ocean's depths, the atmosphere might cool gently above them. Slightly colder waters could support the spread of sea ice, especially in the far north. This expansion would reflect more sunlight, encouraging further cooling. Scientists do not know exactly how these changes might unfold, but the idea remains a soft possibility, a quiet influence that could guide Earth toward a cooler phase. Landscapes also evolve across geological time. Mountain ranges rise or erode. Continents drift into new positions. These changes affect wind patterns, ocean circulation, and how sunlight is absorbed across the surface. In a future thousands or millions of years ahead, small adjustments in geography could gently tilt the climate toward an ice age. A new range of mountains might collect snow more easily. A shifted coastline might alter the path of a major current. These theories acknowledge that Earth's surface is not fixed, but slowly reshaped, and those changes influence climate with whisper-like persistence. The chemistry of the atmosphere provides another distant path. Over long periods, natural processes, weathering of rocks, growth of vegetation, and interactions between the oceans and atmosphere cause greenhouse gases to drift slowly up or down. If, far in the future, these natural processes reduce the amount of heat-trapping gases enough to allow more cooling, glaciers might begin to form again. This is not a prediction, simply a reflection of how Earth's carbon cycle has behaved over millions of years. It is a slow, gentle force, building climate changes with immense patience. Some theories explore quiet volcanic patterns. Earth's interior moves in cycles of its own, and over tens of thousands of years, volcanic activity may rise or fall. If the planet entered a long period of slightly increased volcanic dust in the atmosphere, sunlight could be softened just enough to reinforce natural cooling trends already present. Individual eruptions wouldn't matter. The idea involves long, subtle rhythms inside Earth's mantle, patterns we are only beginning to understand. The thought adds a dreamy layer of possibility to the distant climate, not as a warning, but as the soft outline of a potential path. There are also speculative ideas that reach beyond Earth. Over immense timescales, the sun changes its brightness very slightly. Stars like ours age in quiet stages, and though these changes are tiny, some scientists wonder whether they could contribute to long-term cooling millions of years from now. Even more speculative are theories involving cosmic rays or changes in Earth's position within the galaxy. These ideas remain uncertain and gentle, belonging more to the realm of curiosity than prediction. Yet they offer peaceful reminders that Earth is part of a much larger cosmic environment, influenced by forces that drift far beyond our immediate view. What ties all of these paths together is their softness. None describe a sudden shift or near-term change. They are slow possibilities, faint outlines drawn across thousands or millions of years. If another ice age does come, it will not be abrupt. It will emerge the way all ice ages have emerged, through the blending of small influences, repeating rhythms, and slow adjustments that build their effect gradually. Cooling would deepen century by century, not year by year, giving the world ample time to move through the transition. Imagining these distant paths invites a sense of calm perspective. Earth's climate has always moved in long cycles, guided by natural forces that unfold with extraordinary patience. The future will be shaped by the same gentle rhythms, carrying the planet forward in quiet harmony with the patterns of its past. When people think about ice ages, it's easy to imagine cold arriving suddenly, sweeping across the world in a dramatic transformation. But Earth's climate does not shift in that way. If the planet ever moves toward another ice age, the change would unfold with such deep slowness that no single lifetime would notice its beginning. Cooling would arrive not as an event, but as a long sequence of gentle adjustments, each one subtle and spread thinly across centuries. Imagining this slow movement helps create a sense of calm distance, reminding us that ice ages belong to the rhythms of geological time, not the pace of human history. One of the main reasons another ice age cannot arrive quickly is the enormous stability of Earth's current climate system. The planet is in a warm interglacial phase that has lasted for thousands of years, supported by strong sunlight, active oceans, and a stable distribution of heat around the globe. These conditions do not change abruptly. Even the orbital cycles that guide ice ages shift only by tiny degrees over tens of thousands of years. A slightly cooler summer here or a slightly warmer winter there would make no noticeable difference within a human lifetime. The climate responds only to long, cumulative influences, never sudden ones. Glaciers, too, reveal this slow pace. For an ice age to begin in earnest, snow must linger year after year across vast northern landscapes. It must build into layers, compact, and eventually form ice thick enough to grow outward into glaciers. This process requires thousands of years of cooling. Even the earliest hints of glacial expansion would be subtle. Slightly longer snow seasons, gently shifting vegetation, a faint cooling of ocean currents. These small changes accumulate only with immense patience. No generation would experience the moment when an ice age began, because such a moment does not exist in any sharp or sudden form. The transition is a soft drift, not a boundary. Another reason future cooling would unfold slowly is the complex interplay of Earth's heat systems. Oceans hold vast reserves of warmth that they release gradually into the atmosphere. Even if sunlight diminished slightly due to orbital shifts, the oceans would buffer that change for centuries, preventing quick cooling. Deep ocean currents take hundreds of years to complete a single cycle, meaning any shift in heat distribution would be felt only over distant horizons of time. This slow mixing acts like a stabilizing blanket, smoothing out climate variations that might otherwise lead to faster transitions. The atmosphere also resists rapid change. Greenhouse gases, clouds, and global winds adjust themselves with quiet, interconnected feedbacks. A slight cooling in one region might be softened by warming elsewhere. Storm patterns might shift, carrying heat into areas where cooling tried to settle. These balancing processes work together to maintain climate stability. If a future cooling trend emerged, it would have to persist for many centuries before influencing the deep patterns that govern global temperatures. Vegetation provides additional stability. Forests, grasslands, and soils store carbon, release moisture, and shape wind patterns in ways that resist rapid climate swings. As temperatures drift slowly downward over time, ecosystems adjust in equally slow steps. Forests recede gradually. Tundra expands cautiously. These natural shifts unfold across dozens or hundreds of generations, each one adding a faint influence to the overall climate. The living world never transforms in an ice age overnight. Its changes echo the softness and patience of the climate patterns guiding them. Even the presence of human activity reinforces one simple truth. Rapid ice age cooling is not part of Earth's near future. The planet's climate is currently supported by a combination of natural and modern influences that lean toward warmth, not deep cold. Any eventual return to ice age conditions would have to overcome long-term warming trends and return to the natural orbital rhythms that governed glacial cycles in the past. This shift, if it occurs, remains tens of thousands of years away. The timescales involved are so immense that they create a comforting distance. Even when scientists speak of the next ice age, they are referring to periods far beyond any point we can meaningfully imagine. Tens of thousands of years must pass before the orbital cycles align again in ways that favor persistent cooling. And even then, the early steps would be so gentle that no generation would feel them distinctly. Thinking about these long timescales brings a sense of quiet perspective. Earth's climate is guided by patterns that move at a pace untouched by daily life. The rise of glaciers, the drift of oceans, the soft changes in sunlight, all operate on scales that belong to the planet itself, not to human time. The next ice age, whenever it may come, will not arrive suddenly. It will unfold with the same deep patience that shaped every glacial cycle before it, emerging gradually over ages, silent and serene, far beyond the horizon of our present world. When we let our minds drift far into the future, long past any familiar horizon, the idea of another ice age becomes less of a prediction and more of a quiet imagining. Earth has moved through many glacial cycles before, each one unfolding with deep patience, guided by rhythms so slow and steady that they feel almost cosmic in their timing. If we picture the next distant ice age in this same soft way, it becomes a peaceful scene rather than a dramatic event, a long, gradual transformation shaped by the calm forces that have always guided the planet. In this distant imagining, thousands of years have passed. The orbital cycles that influence Earth's seasons have shifted into new alignments. Summers in the far northern regions have grown slightly cooler, but so slowly that no generation ever noticed the change. Snow begins to linger longer on high plateaus. Thin layers of ice remain at the end of summer, subtle at first, barely more than a memory of the previous winter. Over centuries, these small layers accumulate. They slowly compress into glacial ice, capturing quiet pockets of air from ancient atmospheres. The land begins to hold on to winter a little more each year. The oceans in this distant vision move with the same gentle persistence they always have, but their warmth distributes itself differently. Deep currents carry cool water to new regions, while warm currents shift their pathway slightly, guided by the steady pull of gravity and the slow rise and fall of continents. These changes are not sudden. They unfold like long, patient conversations between water and wind. In our quiet imagining, the oceans help support the gradual cooling, storing cold in their depths and releasing it into the atmosphere in delicate waves. Forests across the far northern hemisphere respond slowly to this quiet cooling. Trees adapted to warmth begin to migrate southward over millennia, retreating as the climate shifts. Tundra plants expand their reach, growing in soft patches where forests once stood. Grasslands spread calmly across open spaces, their colors muted under cooler skies. Animals, too move gently with the changing landscape, adapting at a pace that mirrors the slow drift of the climate. Nothing feels abrupt. The world simply reshapes itself as the centuries pass. As temperatures continue to drift downward, glaciers begin to advance. They grow not with forceful surges, but with steady accumulation. Their movement is measured in inches each year, a pace so slow it feels almost still. Over time, the ice thickens, settling into mountain valleys and spreading into broad plains. The ice sheets become shimmering expanses, reflecting sunlight into space. This reflection reinforces the cooling, helping the glaciers stretch gently across northern continents. In this imagined future, the planet becomes brighter, its light softened by the presence of expanding ice. Farther south, climates adjust with equal patience. Regions that once held warm grasslands shift toward cooler forests. Lakes freeze earlier in the year. The air becomes clearer, carrying the crispness of long winters. These changes follow their own quiet patterns, shaped by geography, altitude, and the subtle interplay between land and sky. People living in this distant world would not perceive a sudden transformation. Their lives would unfold much as ours do now, with the slow drift of the climate settling in over generations, felt only in stories of how winters once were. In our gentle imagining, the ice sheets eventually reach their widest extent. They rest across vast northern landscapes, serene and still, like pale mirrors reflecting the distant sun. The world's climate, though colder, remains balanced. Oceans continue to flow. Winds continue to move. Life continues to adapt. Even during a full ice age, Earth retains its quiet rhythms. The planet does not freeze entirely. It simply rearranges itself, shifting the boundaries between warm and cold, open water and frozen land, forest and tundra. And just as every ice age has eventually eased into warmth, this future ice age would begin to retreat. Thousands of years pass. Sunlight slowly grows stronger in northern summers. Winds shift gently. Snow melts earlier. The ice sheets thin, then withdraw from the edges. Rivers flow again across newly exposed ground. Forests expand northward. The world awakens softly from its long, cool chapter, guided once more by the patient cycles of sunlight and time. Imagining this far future brings a sense of calm perspective. Ice ages are not abrupt or destructive. They are long, gentle movements of the planet through its natural cycles. The next one, whenever it may come, will unfold as peacefully as the ones before it, shaped by soft alignments and quiet rhythms. In this distant vision, the Earth remains familiar, steady, and serene, drifting through the slow turning pages of its geological story. As we drift toward the end of our journey, it becomes soothing to step back and look at ice ages not as isolated events, but as chapters in a long, continuous pattern. These cycles stretch across millions of years, each one shaped by quiet forces that repeat themselves with remarkable steadiness. Understanding these deep patterns helps us see the future not as something uncertain or alarming, but as a gentle continuation of rhythms that have always been part of Earth's story. When viewed from this calm distance, past and future ice ages blend into one soft, enduring tapestry of slow planetary change. One of the clearest patterns is the repeating rise and fall of ice sheets. Long before humans existed, glaciers expanded and retreated in broad, sweeping arcs. These movements followed the same patient rules we observe today. Slightly cooler summers allowed ice to linger. Slightly warmer seasons encouraged the ice to melt. Over thousands of years, these subtle differences guided the growth and decline of ice sheets that shaped continents. When scientists trace these movements through ancient landscapes and climate records, they find a reassuring consistency, as if the Earth has been turning the same quiet page again and again. Another pattern emerges in the relationship between sunlight and climate. Shifts in Earth's orbit gently alter how much warmth reaches the northern hemisphere during summer. These changes are small, yet they appear again and again in the timing of past ice ages. When sunlight waned, cooling deepened. When it strengthened, warmth returned. This repeating connection forms one of the softest threads linking the distant past to the distant future. Just as ancient glacial cycles responded to these variations, future cycles, if they unfold, will likely follow the same calm patterns, shaped by the same delicate geometry of Earth's motion through space. The oceans reveal another deep connection. Throughout past ice ages, ocean currents adjusted their flow in response to cooling climates. Cold water settled deeper. Warm water took new paths. These shifts influenced weather, snowfall, and the global distribution of heat. In every glacial cycle, the oceans played a role, quietly storing and releasing warmth in long intervals. Their behavior formed a gentle bridge between ancient climates and future possibilities. No matter how the world changes in other ways, the oceans remain the same slow, stabilizing presence, guiding climate through soft, repeating rhythms. Ice cores provide a beautiful record of these cycles. When scientists look at the patterns within them, they see clear pulses, cool periods rising, warm periods returning, then cooling once more in a calm, familiar sequence. These repeating waves show that Earth's climate is not chaotic. It is patterned, steady, and deeply rhythmic. The future, even if it brings another ice age thousands of years from now, will do so in harmony with these same ancient pulses. Nothing will break the rhythm. It will simply continue at the pace set by Earth's slow orbit and the gentle breathing of the planet. Even the feedback loops that guided past ice ages seem timeless. Snow lingering longer, ice reflecting more sunlight, oceans absorbing more carbon dioxide. These processes operated softly in ancient glacial periods, and they would operate softly again in any future cycle. They reflect the way Earth responds to change, not abruptly, but gradually, adjusting each element of the climate system through small, reinforcing steps. These feedbacks tie the past and future together, showing that the same quiet mechanisms shape every chapter of Earth's long climate journey. There is comfort in seeing these patterns. They remind us that Earth's climate is guided by stable, predictable rhythms that unfold far beyond human timescales. Past ice ages lasted tens of thousands of years. Their transitions took centuries or millennia. Every shift was patient, every movement slow. Nothing arrived unannounced. Nothing transformed the world overnight. These truths extend into the future as well. If another ice age comes, it will arise from these same peaceful patterns, unfolding gently over ages, not moments. When we imagine this continuity, the story of ice ages becomes less about cold and more about rhythm, less about change and more about time. Past and future cycles blur into one long, serene flow, shaped by orbital motions, ocean patterns, atmospheric shifts, and the steady heartbeat of the planet. Earth has been following these patterns for millions of years, and it will continue to do so, drifting through its climate cycles with the same quiet grace. Seeing these deep connections brings a sense of calm understanding. The next ice age, whenever it arrives in the far reaches of time, will not be a disruption, but simply the next step in a long, natural sequence. The planet will move into it as gently as it has moved through every ice age before, guided by slow forces, soft rhythms, and the deep, patient turning of Earth through space. As we reach the end of this quiet journey through ice ages, one final theme rises gently into view: the soft uncertainty that surrounds Earth's distant future. Not an unsettling uncertainty, but the kind that naturally comes from trying to imagine events that unfold across tens of thousands of years. Earth's climate has always moved through long, patient cycles, influenced by subtle forces that shift so slowly it can take entire civilizations to notice their progress. When we hold this timescale in mind, the future becomes a calm expanse, open, slow-moving, and filled with possibilities rather than predictions. Scientists understand many of the rhythms that shape ice ages, yet there are still delicate mysteries woven into the climate system. Some of these mysteries lie in the oceans, where deep currents move with a patience that can only be measured in centuries. Others lie in the atmosphere, where faint patterns of moisture, dust, and cloudiness influence temperature in ways that are still being gently uncovered. Some mysteries extend into the sun, whose brightness and magnetic rhythms shift subtly over time, and others reach outward into cosmic space, where distant forces may leave faint imprints on Earth's climate, far beyond the scale of everyday experience. None of these unknowns disrupt the calm. Instead, they add a soft shimmer of wonder to the long story of ice ages. One of the most soothing truths about the future is that the next ice age, if it comes, will follow the same deep, patient pace as all the cycles before it. It will not arrive suddenly or dramatically. It will unfold through small steps, slightly cooler summers, slightly slower melts, slightly expanding regions of snow that linger at the edges of each year. These gentle signs will blend into the background of centuries, noticeable only when seen across long arcs of time. That is the nature of ice ages. They belong to the planet's slowest movements, shaped not by yearly fluctuations, but by the quiet geometry of Earth's orbit and the subtle breathing of its oceans. There is also comfort in knowing that Earth's climate is resilient. Through immense volcanic events, shifting continents, and changes in atmospheric chemistry, the planet has always found its way back into balance. Warm periods rise, ice ages fall, warmth returns again. These cycles create a gentle rhythm that stretches backward into deep history and forward into the farthest reaches of the future. The details may shift, but the overall pattern remains one of calm, repeating harmony. Even in the face of uncertainties, this long view offers a sense of stability that is both grounding and peaceful. When we imagine the future, it's helpful to picture it in the same dreamy, expansive style we used to explore the past. Perhaps thousands of years from now, Earth drifts slowly into another cooling phase. Snow begins to linger a little longer in the far north. Glaciers gather themselves patiently along rugged mountain slopes. Oceans adjust their currents. Winds take on new patterns. Vegetation migrates gradually. Each change unfolds in soft increments, stretching across generations, none of it abrupt or unsettling. Life adapts gently. Landscapes shift quietly. The world continues its long conversation with time. Or perhaps the orbital rhythms remain in configurations that support extended warmth. The interglacial period continues longer than usual. Ice ages, which once arrived with predictable regularity, may pause for a time, waiting for the right alignment of celestial and terrestrial influences before beginning their next chapter. This too is possible. Earth has seen long, warm intervals in the past, and the future may hold another. The uncertainty is not a source of worry. It is a soft space of possibility, shaped by the planet's natural rhythm of change. In many ways, the distant future becomes a reflective mirror. It shows us how small we are in the vastness of geological time, yet how deeply connected we are to the cycles that shaped every landscape, every valley, every shoreline. The future ice age, whenever it arrives, will be part of this same continuity. It will come like a calm tide, rising slowly on the horizon of deep time, shaped by forces that move with extraordinary patience. Long before it becomes noticeable, its foundations will have formed quietly through thousands of gentle shifts in snow, water, sunlight, and air. What remains is a sense of peaceful humility. Earth moves at its own pace, guided by processes that operate on scales far beyond human experience. The next ice age is not a question of fear or urgency. It is simply one more chapter in a story that has unfolded for millions of years. A story written in ice and warmth, silence and motion, sunlight and time. Letting this perspective settle around you creates a feeling of deep calm. The future is vast, slow, and serene, shaped by natural rhythms that continue their steady flow regardless of the moment. And as you drift away from this exploration, the entire subject becomes like a soft echo, one that lingers quietly, reminding you of the gentle, enduring patterns that guide our planet through its long and beautiful cycles. As our long, gentle journey through Earth's ice ages comes to a close, the world around you can begin to soften, just as the planet itself softens into each of its slow climatic rhythms. You've drifted through ancient landscapes carved by ice, breathed in the calm silence of deep oceans, and wandered through theories that stretch across tens of thousands of years. Now those ideas can settle lightly in your mind, like quiet snowflakes drifting onto an untouched field, softening everything into stillness. The Earth you imagine tonight has existed in many forms. It has moved through warmth and cold, through glacial centuries and gentle thaws, always guided by rhythms too slow to feel and too vast to measure by ordinary time. These patterns continue whether we look at them or not, unfolding patiently across the arc of deep history. There is something deeply calming in knowing that the planet changes in such serene, unhurried ways. Nothing in the ice ages arrives suddenly. Nothing fades abruptly. Every shift is a whisper stretched across generations, a reminder that nature prefers slow motion, quiet balance, and long intervals of rest. As you drift away from these thoughts, picture the Earth from far above, turning steadily beneath soft layers of cloud. The continents, shaped by ancient ice, lie peacefully in their current forms. Oceans shimmer with reflected light. The poles rest under blankets of snow. Every part of the planet feels grounded in slow, natural rhythms. Even the possibility of future ice ages becomes a gentle idea rather than a distant question. Something that exists far beyond the horizon of human time, woven into cycles that will unfold long after this moment has passed. You might imagine those distant futures now fading into the background, becoming a soft blur of quiet possibilities. Snow lingering on high mountain ridges, oceans drifting through slow adjustments, winds shifting with patient precision. These images can dissolve like morning frost, leaving only a sensation of calm, wide open space. The world you imagine tonight is not one of urgency or fear. It is a world shaped by patience, a world guided by forces that move with the deep tranquility of geological time. If your thoughts begin to wander, let them drift in the same way Earth drifts through its long cycles, slowly, lightly, without effort. You don't need to hold on to any detail. Every idea can simply float by, like glimmers of sunlight reflected off distant ice. There is no need to make sense of anything now. You've taken in enough. You've traveled far, not through space, but through time measured in gentle, sweeping epochs. That journey can settle now, easing into quiet rest. The vast scale we explored tonight has a way of putting everything into perspective. The ice ages remind us that change is natural, but also that change is slow. They show us a world that moves with grace, adjusting itself through tiny increments that accumulate over ages. And in that slow movement, there is a stillness, a restful rhythm that invites you to breathe a little deeper, to loosen your thoughts, and to let yourself drift gently towards sleep. As you rest, imagine the Earth continuing its patient rotation beneath a blanket of stars. Imagine the long arcs of its orbit, the soft tilt of its axis, the faint pull of distant forces shaping its path. These motions will continue through the night, through the coming days, through generations and ages far beyond this moment. They ask nothing of you. They simply move quietly and steadily, just as your thoughts can now move into a softer, quieter space. And in this gentle stillness, you can let the entire weight of the day slip away. Let your breath settle into a slow, comfortable rhythm. Let your body grow heavy and warm. Let the peaceful patterns of Earth's long story surround you like a calm, endless night. There is nothing more you need to think about, nothing more you need to imagine. Only a quiet space, a drifting mind, and the soft turning of the world beneath you. Whenever sleep comes, it will come gently, arriving with the same patience and serenity that guide every ice age, every ocean current, every whisper of wind across the planet's surface. Let yourself drift into that calm now, resting at the edge of deep time, where everything moves slowly, everything feels steady, and everything is peaceful.